Okay, welcome back. Today we're going to be looking at solving quadratic equations using a method that we call completing the square. We've talked a little bit about this already. Hopefully we can clear up any issues you might be having with it. Remember that anytime we want to complete the square, the first thing that we're always going to want to do is make sure whatever remember, when we have a quadratic, we have three terms. We have what we call the quadratic term with the x squared, we have the linear term, and we have the constant term. And we always want to make sure that the first term, or the quadratic term, is nothing but positive x squared. So whatever is there, we want to get that out of the situation if there's a coefficient in front of x squared. After we do that, we're going to move the constant term over to the other side of the equation. We'll either subtract it off or add it on to both sides to get rid of it from that side that has the quadratic term. After that, we're going to get into what we call completing the square. To do that, we look at the linear term, and whatever number that is, we'll take half of that and we will then square it. Okay, remember we put it to the second power. Now once we do that, we'll add it to both sides, and then we'll get into factoring the trinomial. And the trinomial is always going to factor a specific way, and that's by design. Since we've completed the square, that'll happen a certain way we'll look at in a minute. And then we're going to take the square root of both sides of the equation. Now we should always remember as well, anytime we're working with a quadratic equation, we're going to get two answers. Now, the two answers might be in the form of the same answer. Sometimes that's a certain situation that happens from time to time. However, we usually are going to get two answers, either both rational numbers or maybe even an irrational or even an imaginary number, but they're going to be two answers to our problem anytime we're working with a quadratic. All right, all that said, let's jump in and look at a couple of examples and clear up all the information we've talked about. The first thing we're going to do is look at this problem here, x squared minus 14x plus 33. And I've got the little checklist over here that we're going to go through and make sure that we follow the steps and understand what's going on. The first thing is make sure the first term is positive x squared. Well, in this case, we look there and we do have a positive x squared as our first term. Then we're going to move the constant term over to the other side of the equation. We have a constant term of 33. We're going to get it off of this side of the equation by subtracting it off. And of course, it's an equation, so we have to subtract from the other side. In doing so, we're going to have x squared minus 14x left on this left side of the equation. On the right side, I will have a negative 33. Now, you'll notice I left a little area there. We're going to be putting something in that space momentarily. But we have moved the constant term over to the other side now. Now the third step says complete the square. And we do this by taking half of the linear term and squaring it. The linear term in this case is negative 14x. We're going to take half of that, which would be negative 7x, or I guess we can just call it negative 7. We'll just deal with the coefficient really. So we're going to take negative 7, and we're going to square that. And when I square negative 7 times negative 7 is positive 49. So we add 49 to both sides of the equation. So at that point, we're going to have x squared minus 14x plus 49 is equal to negative 33 plus 49 is 16. So we have completed the square at this point. The next step says factor the trinomial. As we factor this, it's always going to factor into a perfect square. So we know that that's going to happen every time. And some people wonder what's going to go here. It's always going to be this value that comes down and goes in that spot. So we had a negative 7 there. So we know without a doubt this is going to factor to x minus 7 squared, provided we've done everything correctly. If you want to go through your longer process of factoring, hopefully you would find that this is x minus 7 times x minus 7 or x minus 7 squared. It's still equal to 16 over here. So we have factored the trinomial. Our last step says take the square root of both sides of the equation. In doing so, we're just going to take the square root of this side and the square root of this side. And in doing so, the square root of x minus 7 squared, when we take the square root of something that is squared, they basically just cancel each other out. They're inverse operations of one another. So we're left with...
Good morning.
Sorry about that, we had a little interruption there. But continuing along, when we take the square root of this, the square is going to cancel out, and we're left with x minus 7. And one thing to remember when we take the square root of a number, particularly this number on the other side, we're going to get a positive and a negative value. That's always going to happen. So we know that the square root of 16 is typically 4, but it's also negative 4. So we have to consider both answers. So we get positive or negative 4, and that's a place where a lot of people tend to make a mistake. So make sure you recall always that we are going to get a positive or a negative value for that square root. The last step, of course, is going to be to solve this out. So we're going to add 7 to both sides, and that's going to give me, just come over here, I have x left on the left side, and then I'm going to have positive 7 plus and minus 4. So we take that and break it down. That means basically 7 plus 4, and x is equal to 7 minus 4. Remember, this sign basically just means both operations are there, plus and minus. So 7 plus 4 is 11, 7 minus 4 is 3, and we finish with our answer of x is equal to 11 or 3. So we have taken the square root of both sides and we've solved for x. And we got our two answers. Now, sometimes this method, you can probably already tell, takes a while to go through, and it's not quite as simple. If you know how to factor and you can factor it quickly, that might be the best method in some cases. However, in some cases you can't always factor, so we need to explore other methods. Completing the square is one of those methods. All right, let's look at another example. Solve by completing the square again. Remember, we go through our steps. Our first step is to make sure the first term is positive x squared. Well, we don't have a positive x squared here. We have 2x squared. So we're going to remedy that situation by dividing everything by 2, since that 2 is being multiplied to the x squared. In doing so, we're left with x squared plus 7 halves x, and yes, that is a fraction, we'll be okay, minus 4 divided by 2 is 2. Okay, so we've divided everything out to make sure we have a positive x squared as our lead term. Number 2, step 2, make sure the constant side is moved to the other side of the equation. Well, that's this minus 2 here, so we're going to add 2 to move it out, and we'll add 2 to the other side of the equation. So we are left with x squared plus 7 halves x is equal to 2. And at this point, we've done the first 2 steps. We have to now complete the square. And we're going to take half of the linear term and square it. We mentioned this in class the other day. To take half of a fraction, you are going to double the bottom number. Okay, that's basically how we take half of any fraction. We just take the bottom number and double it. So we get 7/4. Now we're going to square 7/4. You square 7/4 by squaring 7, which is 49. And we square 4, which is 16. So we're going to add 49/16 to both sides, recalling that 2 as a whole number is 2 over 1. And that'll come into play here in a moment. Now we've completed the square, and then we're going to factor the trinomial. Okay, again, we know every time that this is going to turn into a square binomial, so we'll have x with something being squared. So in this case, it's going to be plus 7/4. So we've got x plus 7/4 squared. And over here, we've got 2, and we're going to add 49/16 to that. Remember, you have to get a common denominator. That would be something over 16 would be our common denominator here. So as I convert 2 to something over 16, that would end up being 32/16. So I have 32/16 plus 49/16, and that gives me a total of 81/16, which is actually a very good number to work with, and we'll look at why in just a moment. So we have factored the trinomial, and we've got everything simplified on the right side of the equation. Now we're going to take the square root of both sides. So I take the square root of this side, I take the square root of this side. In doing so, remember the squared and the square root will cancel each other out, so we're left with x plus 7/4. And the square root of any number is going to be positive or negative. To take the square root of a fraction, you take the square root of the top number, and then the square root of the bottom number. The square root of 81 is 9. The square root of 16 is 4. So we get positive or negative 9/4. Now, I'm going to come over here and finish this, but we have taken the square root of both sides. Now all it just turns into is just a simple linear equation. We've got x plus 7/4 is equal to positive or negative 9/4. And again, if you want to think of this as two problems, x plus 7/4 equals 9/4, and then x plus 7/4 equals negative 9/4. That's one way of thinking about it. Or we can try and do it all at once you become comfortable. But to do this, we're basically just going to subtract 7/4 from both sides of this equation, and that would leave me with x is equal to 2/4, which we'll simplify in a moment. And then coming over here, minus 7/4 from both sides leaves me with x is equal to negative 16/4, which again we can simplify. So let's simplify those final answers. X is equal to 2/4 squared, or excuse me, 2/4 simplified would be 1/2. Or over here, negative 16/4 simplifies to be negative 4. So our answers are x is equal to 1/2 or negative 4. And again, we have completed the square by going through our process to solve the quadratics by this method. Let's look at one more example to emphasize the point that sometimes these don't always work out quite as nicely. We'll go through this one a little bit quicker, but we're going to go through the same steps. We start off again, make sure the first term is positive x squared. Hopefully you'll remember, we want to do that by taking everything in the problem and dividing it by that coefficient of 2. So I'm dividing everything by 2, so that now I have x squared. I have 5/2x, or 5/2 x, plus 3 is equal to 0. Continuing along, the next step is to move the constant term to the other side of the equation. That means we're going to subtract 3 off of that side of the equation. So that gives me x squared plus 5/2 x, and it leaves on this side negative 3. Then we are going to complete the square by taking half of the linear term and squaring it. Half of 5/2 would be positive 5/4. Remember, you just double the bottom number. Now when we square positive 5/4, we're going to get positive 25/16. So we are going to be adding 25/16 to both sides. And we got 3/1. That's going to give me, when I go to, or that's completing the square, so now I'm going to go to factor the trinomial. I'm going to have x, something squared, and it's always going to be this value here. So it's going to be x plus 5/4 squared. And then I come over here. Again, I want to get a common denominator. In this case, between 1 and 16, the common denominator. Okay, we'll continue again. Sorry about that interruption. So we're going to get a common denominator between 1 and 16, and that is going to be 16. To get this 1 to turn to 16, we have to multiply 16. So I'm going to do the same thing to the -3, and I get -48 sixteenths plus 25 sixteenths. Now in this case, that is going to equal -23 sixteenths. Now that negative value is going to come into play here in a moment, but just, hopefully you follow how I'm adding these fractions. I know we're not always all that strong at that skill, so hopefully you can follow along with what's going on there. But we continue now. We're going to take the square root of both sides of the equation. And that's going to give us a little interesting situation in this case because we do have a negative number. But on the left side, we're left with x plus 5/4. On the right side, I'm going to take the square root of the bottom, and remember we're going to get plus or minus. We take the square root of 16. Square root of 16 is 4. And then we take the square root of -23. Now you'll remember that I mentioned this in class that we're, well, for right now I'm just going to write it like this so you're understanding what's happening. We're taking the square root of that -23. Now you'll remember that I mentioned in class, and we haven't spent a vast amount of time talking about this, but anytime we take the square root of a negative number, we're going to pull out an I in front of the radical to basically indicate that this is an imaginary number. There are no numbers that have been squared that equal negative. So because of that, you can't get a square root of a negative value. So we'll talk more about this later on, but that is called an imaginary number. So we're going to put an I in front of it. And then we have the 4 here. Okay, so to solve this, now we're going to subtract 5/4 to get x by itself. We'll subtract 5/4 from both sides. So we're left with x on the left side, and we have -5/4 plus and minus I square root of 23 over 4. Now, if we really wanted to continue and write this out properly, since these both have a common denominator, we can just combine them into one fraction. The top we would just add together as -5 plus or minus I square root of 23, and then put a common denominator of 4 on the bottom, and there is our answer. Now remember, we're supposed to get two answers. This plus and minus here is where those two answers are coming from. You have -5 plus I squared of 23 over 4, and -5 minus I squared of 23 over 4. So we get our two answers through having that plus and minus there. That's why it's very important that we recall every time that we take a square root, we should put that plus and minus there on the right side of the equation to make sure we get our two answers. Okay, well that's a good little review for us right now. If you're having additional questions, please make sure you speak to me in class or come to a tutorial time. Good luck with everything, and remember, the best way to get better at these is to continuously practice them until you've mastered the process. Sometimes the problems will get ugly, but if you stick to the process and go through your steps every time, I think you'll find that you can do just about any problem or solve just about any quadratic by using this method. Have a good day.